Hey guys, what's going on? So today we're going to take a look at a workshop we're building on Solana where we're going to actually do like kind of as the page suggests, we're going to generate an SVG from some on-chain data. And for those of you guys who don't know what an SVG is, it's basically like an image described using like XML tags and stuff. So what we're going to do is we're going to put all of those tags into one big string, and then we're going to store that string into an account on Solana. And then we can load that account's data to serialize that string and render it as an SVG in the browser. So as you can see here, I've got these QR codes. This is just for when I'm conducting this workshop in person. That'll just route you to a couple different links. So that's all that is. And then you can see here that I've built this in a way where you guys can actually clone this down locally and you can plug in your own program ID and see it work. So to get started, here's the code. And I built this with the Solana DApp scaffold. So that's what like all these files are going to be. This is all Next.js, and all this stuff kind of like comes out of the box. So I'll show you what that looks like. I've mentioned this in other videos, but basically this is the DApp scaffold. And it looks a little different now because it's been sort of enhanced recently. It looks a little bit newer. But this is what I used to build this thing on the previous version, which kind of looked like this. And you can use this npx create Solana DApp command to actually gen one of these scaffolds and use it. So it gets you up and running pretty quick. And I'll show you some of the cool features that it adds, like this context provider. It'll add you the ability to add different wallet support to your app. It'll give you like a nav bar and stuff with the wallet button to connect those things. You can do request airdrop, like all these things sort of come out of the box, and then you can just like add all of your customizations on top of this thing. So it's pretty neat. There's a lot of other stuff in here that you might want to take a look at, like some hooks and some stores, like getting a user soul balance and things like that. So what we used were const, which is just going to be my network, that's all. And then I used this QR code gen to get those QRs on the screen for the links. But this right here, SVG-generator, is the only one, and also workshop links has to do with that QR. This is the only one that we really need to care about, right? So let's take a look briefly at what's in here, and then we'll take a look at the program and come back, right? So for starters, I'm going to skip all this stuff up top for now. But basically, right below our QR code section, you can see here we're entering the program ID, and then we're doing this on-click generate SVG. And then here, once we have an SVG string present in the state, it starts as null or undefined, then it'll show it on screen. And so if I just want to demo this to you guys, I can grab my latest deployments ID and I can just plug that in and hit generate. And it's going to ask me to, I'm pretty sure I'm on localnet, so I don't think this is going to work, but it's going to ask me to approve. Yeah, I need to be on DevNet. One sec. I know you guys probably love my UI development as well. It's very intricate. But I'm going to refresh. Now that my wallet's on DevNet, I can paste my program ID and I can hit generate. And it's going to request that I approve this transaction because it's going to debit me a little bit of SOL for the transaction fee and the rent to create this account for the SVG. So if I approve it, then there is our SVG on screen right now. So you can see we just get a random SVG. And if I run this thing again, I'll again approve and I will get another random SVG. Same color this time, but it'll change colors eventually. And so we can take a look at the code and see how this is actually built. But like I said at the beginning, this is literally just loading data from a Solana account. And I promise it changes colors. Try one more time for a color change. Woo, yay. So anyway, like I said, we're loading this string from an on-chain account, and it's going to be sitting there on the Solana blockchain in bytes. So we have to serialize it to bytes with our program, put it into that account, and then we have to load it as bytes from the chain and then deserialize it back into a string that we can read as an SVG. So one thing that's going to be useful for you guys is if you look at this README, you can actually see some diagrams of how this thing kind of works. right? So this right here is going to be exactly how it works. Our client, our front end, is going to send an instruction in a transaction to our program. It's going to use the system program to actually create this new account, and then it's going to write the data to that account, right? And then there's a little bit more information here about like how transactions work, how instructions are kind of structured, and some intricate details about that flow. So you guys can take a look at this anytime you want. But this top one here is going to be what we need. So I'm going to close these out, and I'm going to pop open our Rust program here. So I'll close our app folder, and I'll open this SVG-generator folder. And then right here, we've got librs, which is going to be almost a single file Solana program. And then this SVG file that's really going to be responsible for building that string. So I'm going to talk about how this kind of works. Basically, what we've got going on here, and I'll get to the program part in a second, is we've got these 4 numbers coming in as random numbers, right? And the reason I put random in quotation marks is because it's really not possible to do random in a smart contract. What you have to do instead is use an oracle and use like a random generator number oracle. So it's a little bit complicated. It's beyond the scope of this tutorial, but the point is that's not how this thing works. This thing is we're going to generate random numbers on the client side and send them to the program. And using those random numbers, we're going to take those as the indexes of various vectors of strings and use those to build a string that we're finally going to return in this struct in the image field, right? And so these annotations for Borscht deserialize and Borscht serialize are going to let us actually go to and from bytes with this data. So if we're coming in with these 4 random numbers, if you scroll all the way to the bottom, you can see here is where I'm using them. So I get a new SVG, new with root, and that basically just means like, here's all the beginning string. And then we use each index to tack on additional items to our string, finally ending with the closing SVG tag. And then we return that thing in the SVG object, which is of course going to constantly be updating that image field, right? So then we get back an SVG, and that string is going to be just a big like XML representation of an image like we talked about. So that's what's kind of going on. This is our account state, and this is our instruction data. And so in this very simple program, that's exactly what we're going to see happening, right? So we're going to have these as our input. And if you look, that actually lines up perfectly with what we saw in this diagram here, where we saw this transaction has these instructions and they look like this, right? And that's exactly what we need to pass into our program. Every Solana program needs to be able to take these in at its entry point. And so that's why we define the entry point as the SVG generator function, and it takes the same things, right? The only difference here is these aren't just public keys anymore. When they hit our program, they're fully loaded accounts, and they're loaded from the blockchain. So anyway, we let our random numbers variable equal this random numbers object, and we're going to do try from slice, which means try to deserialize these bytes into this struct. If that's successful, we can continue with the rest of the program where we're going to load our accounts. That's going to include the new account that we're going to be creating, and then the one who's going to be paying for that new account's rent. And so here's where we do that new from randoms function call, which is just going to give us, like we saw, an SVG object returned. It's going to use those random numbers to build that string like we just saw. And then finally, what we have to do is we have to calculate how big that object is. How big is that struct with all of its string representation of an SVG? And we have to calculate the required rent for it. And once we have this information, we can then go invoke another Solana program. And when you see this function invoke or invoke sign, that just means our program isn't capable of doing this particular thing. So it's going to go invoke another smart contract on Solana, ask it to do an operation, and then get back a result. And so this question mark right here just means like, hey, did it, work successfully? If not, throw a result and kind of like return a result on this function. So that's what that's going to do. And if that comes back successful, that means the system program, the program that we just hit and asked to create this account, has created this account for us to put this SVG data into. But we've also designated our program as the owner, which means once it's created, the system program will assign the owner being our program, And that means instantly our program is able to change the data in this account. So it's important to realize that when you create a new account, it starts as empty, even though no matter how big you say it's going to be, it doesn't actually get any data into it besides its balance of soul and a couple other additional fields. It doesn't get any custom data until you write to it. So we set our ownership as the program ID. And then when this finishes, then we do our write right here. And that's us writing to the account's data. Again, if that's successful, we'll continue onto this OK, and then we're done. So that's a very entry level program, guys. Like this is just us taking some inputs, parsing from the bytes coming in. This is us loading up our accounts that are going to be involved. We're creating some data. We're calculating the rent for that data. Then we're creating an account using a cross program invocation. And then we're serializing data to that created account and returning an OK result. And that's it. That's our program. So like I talked about at the beginning, this SVG, and this yellow one is super ugly, by the way. I'm going to try to get a better one going. This SVG is stored in that account data, and our browser is actually loading the data from the blockchain, deserializing it into like a JavaScript type or a JavaScript class, and then rendering that image field, that string, into an SVG. And because we see the image here, we know that it was a valid like SVG XML tagged object. So let's take a look at what that kind of looks like on the client side. So we saw our program. We know that as long as we hit our program with the right instructions, it's going to write that stuff to the chain. So if we take a look at our util function here, this is actually going to be what does some of that legwork for us. So you can see we've got an SVG data class, and it has the same field that we saw in our SVG struct in the Rust side of things. So if we pop that open again, here you can see that we've got, again, see how this looks. We've got our SVG data struct with image, and here we've got an SVG data class with image. And Rust is going to let you just add this annotation, which is going to do a bunch of that Borscht serialization methods implemented for you. In TypeScript, it's not so easy, right? Like we have to actually do some of that work ourselves. So we have to add this from buffer function. That's going to use Borscht, same library, just in JavaScript, to deserialize this object. But we also have to leverage this schema. And the schema is like what defines what this thing actually is. And you can see that in both cases, it's a string, so it looks the same. But if we look down at our random numbers object, which in this case is going to be our input data for our instruction, this time we're doing to buffer, serializing, but we're still using a schema. And look at this schema. We actually say U8. So in Rust, that's what we got, U8. But in JavaScript, or TypeScript rather, we're just calling it a number. And that could be any bit number, right? Up to a certain extent, up to a BN. So here, what we're going to do is actually tell Borscht what specific size number this is going to be. And that's crucial for the type of bytes and interpreting those bytes that it's going to create and do. So anyway, down here is where I'm actually using math.random to create those random numbers. We cap it at 5 because that's how big these vectors are. And so for random numbers, we go ahead and pipe that in to this constructor, and we get a random number class that we can then run to buffer on, turn it into bytes, put it into an instruction, and send that instruction to our program. So I'll close this out. And that's actually exactly what's happening up in our component, right? So we saw some of this stuff already, but if you look at the on-click generate SVG function, that's this big guy right here. And so first we load our program's ID, and that's the one that we're going to be putting into that field, of course. And you can see that that's involved in creating this instruction, which again looks exactly the same as the pattern we've seen. We pass in the accounts required, and then finally we do this get random number data, which is going to be taking this information, generate random number, get random number data. It makes this class, and then it runs to buffer. So our return is a buffer, right? And that's exactly what we need here in this data property. So we pass in the buffer, and that's going to have our instruction data with the random numbers. We know the accounts that are required. And here to create this SVG, we're just generating a new random key pair. And so for that reason, we also need that key pair to sign this transaction. So down here, we build a transaction, we add that instruction for our program, we calculate the latest block hash or just go get it from an RPC call, set that in the transaction, set our fee pair, sign with the new SVG account's private key, and then finally we use the send transaction function that comes from the wallet. And that's going to prompt our user for a signature if they need a signature, which in this case they're the fee payer, so they're going to have to sign. They're also paying the rent, um, which they're provided right here to do so as well. And is signer true. So two spots that we need to sign for, one signature, but for two authorizations. And then we'll send that transaction to the Solana runtime. We'll confirm its signature. And then when we're done, when we confirmed it and we know that that transaction was sent and processed and confirmed, then we know that this account now exists. And if our program didn't fail, that means we know it wrote data to the account. So we can do this connection.getAccountInfo. We can look up the SVG account. And then you can see that we're going to just grab this data, right? So we're going to do SVG data from buffer. And then we're going to run that on the account's data field, which is going to be a buffer. And then we'll get the image property of that object. And that will give us our string from the blockchain, right? So I just want to really quickly do a console log in here just so we can see this. So I'm going to just do console log, and I'm going to do SVG pub key and just do SVG account.pub key. And that'll just show it to the log what that pub key is so we can take a look at it. So anyway, let me run this bad boy one more time. We'll see that I got to approve once again. We'll get a new, oh, whoops. We'll get a new SVG, cool blue color. And we should see our SVG pub key and a bunch of questionable logs. But regardless, right here is the public key. So because this is a native program, we're not going to be able to see any of its data on the Solana Explorer. But I'll show you that it does in fact exist. So go to DevNet, take a look. You can see our program is the owner, which is cool. You can see the size of our account data is not 0, so we know there's some data in there. And if this was an Anchor program, you could have a tab here that would show you its deserialized data. That's because Anchor uses IDLs, but this program does not. So you can see the transaction where this was created though, and we can see down here in our transaction, we have create account and then some unknown program logs. But in this mix is where we're actually going to be getting the serialization step right after this is done. So pretty cool stuff. You can a little bit see what this kind of looks like on the console if you do like if you do Solana account and you pass in the public key. And you can see our string is in there, right? But it's very like truncated and like doesn't really look all too clear, but you can see the starting SVG tag and the finishing one, right? So it's there. And here's all of the bytes that make up that string. And this is actually how it's stored in that account, which is kind of cool to look at anyway. But you can see that something is in there. And then as long as our browser is able to render this SVG successfully, that means we probably have valid tags in there, right? So that's really it, guys. That's how you basically take an on-chain data account, like something that has custom data, and load it into a browser. In this case, I'm demoing it with an SVG because it's something that's very like particular about its formatting. But you could do this with just words. You could do it with numbers. You could do it with anything. As long as you can tackle the serialization aspects of things and setting up these schemas to be able to go from JavaScript code to bytes to Rust and then back, right? That's basically the whole thing. Because on Solana and passed into Solana, it's going to be bytes. But in these programming languages, it's going to be their own like data representations. So kind of cool. And just for reference, like this SVG is just right here. You just do SRC, that's going to be the string, right? So, but that's it, guys. Have some fun, fool around with this. I encourage you to clone it down, boot it up, and deploy your own program and try to modify it and see if you can like change the SVG or like do whatever and just plug your program ID in right here and see if you can get it to work. Cheers.